Okay, here we're going to learn how to use the resistor color codes in order to make a determination for the nominal value of a standard resistor. So one of the first things that we should know is that in the lab we're generally going to be working with the 4-band color codes, but always pay attention. Just take a quick peek here. Let me put a resistor in focus here, and here we can see that there's 3 bands that are in closer proximity to each other, and then there's a 4th band off to the side. And we'll have these color codes here in the lab at your workstation, but you can also find these on Google, and they even have color calculators that you just punch in the color and it tells you the value. But this is a useful skill to know, and you'll become familiar with some of the colors and be able to reference the value just by that. So as we look at the resistor, we notice that there's those 3 bands that are closer to each other, and then the 4th band off to the side. So let's just make note of what those colors are. So first we have brown, then we have black, then red, then gold. Now with a 4-band color code, the first 2 colors refer to the digits. The 3rd refers to the multiplier. The 4th refers to the tolerance of the resistor. So then I'm going to take my guide here and I'm going to look. Okay, brown has a value of 1. Black, 2nd digit, has a value of 0. Now this is what trips people up. With a 4-band color code, the 3rd color refers to the multiplier. Sometimes this will be expressed as 10 to some exponent. In this case, this color guide just provides you the actual factor that you should multiply by, right? And so red is 100. So we're going to say times 100. I'm writing that down. And then gold, it's almost always going to be gold unless you're working with a different type of resistor, maybe a 5-band resistor. It's going to be plus or minus 5%. That's the tolerance. We'll talk about that later. So how do I determine the nominal value from that? I just go ahead and put those 2 digits together. It's 10 times 100 equals 1,000 ohm, right? Okay. So what does the tolerance refer to? This is the nominal value. The tolerance is plus or minus 5% of this stated value. Plus or minus 5%, that equals, in this case, 50 ohms. So you can expect that if you were to make a measurement on this resistor, it will vary by as much as 50 ohms. Okay, let's move on to another resistor. Let's just see if we have this down pat. In this case, our resistor has a color code of, this would be, I'm looking at this correctly, that's violet, green. I'm actually trying to look to the camera, so just so I see what you see. Violet and green. And that is not wanting to focus. Brown, gold. Again, go to the color guide. Violet is 7, green is 5, brown times 10. So what is the nominal value? 75 times 10 equals 750 ohms. Okay. Now I have, you can play around with resistors and make sure that you can calculate the nominal value. Let's see what the actual values of the resistors really are. So in this next video, we're going to use the multimeter to determine the value of this resistor, which we said had a nominal value of 750 ohms, and this one, which we said had a nominal value of 1,000 ohms, 1 k ohm.